In this section, we're going to use the distance formula to calculate the distance between any 2 points B and A. In order to do that, we're going to make use of the Pythagorean theorem. And you can refer to this picture as I go through some of the notes that we're going to talk about. To calculate that distance between those 2 points A and B, we're going to draw a line between them. This is going to be called the hypotenuse of the right triangle. A right triangle is one that has a 90-degree angle in one corner. Then we're going to make a right triangle that has sides or legs AC and BC. We're going to measure the distance of those two sides or those two legs and call them A and B of the right triangle. Then we're going to use the Pythagorean theorem. The Pythagorean theorem states that the hypotenuse squared, or here we label it with the letter D for distance, is equal to the square of the two legs added together. So that means that we would take A squared plus B squared would equal to the hypotenuse squared. The way that we're going to use the Pythagorean theorem is to take the square root of both sides, which will mean that the distance is equal to the square root of A squared plus B squared to find our distance. Let's take a look at a couple of very specific examples. This one is called a 3, 4, 5 right triangle. If one leg is equal to 3 and another leg is equal to 4, in this case the hypotenuse has to equal 5. We can try it into our formula where the distance squared, or the hypotenuse, is 5 squared, which is 25. One leg is 3 squared, which is 9. The other leg is 4 squared, which is 16. 9 and 16 is equal to 25. So this example works. Let's try another one. Let's try 6, 8, and 10. So 10 squared for the hypotenuse is 100, 6 squared is 36, 8 squared is 64, so again 100 is equal to 100. This won't be the case with all numbers that you pick. This just happens to work for these very specific examples. Let's try another one and see if you can figure this one out. If we had two legs that were 12 and 16, what would the length of the rafters have to be? I'm going to pause the video right here, or you can pause it and see if you can figure it out, and then I'll continue with the answer. Here's how you would work this. This is another application of a 3, 4, 5 right triangle. I have the legs labeled in green with the 3, 4, 5. I have their multiplier of 4 highlighted in the yellow, and you can see then that the lengths of the legs would have to be 12, 16, and 20. You can put those numbers into the Pythagorean theorem and check and make sure that it works. But in general, any numbers that any multiplier that you take by 3, 4, and 5 will make something that will work for the Pythagorean theorem. Here's how we're going to use the Pythagorean theorem, or the distance formula, for our class. We're going to pick 2 points. We're going to have this point up here, which we're going to call x sub 1, comma y sub 1, and this point down here, which we're calling x sub 2, y sub 2, and find the distance in between those, as shown by this hypotenuse right here. The way that we're going to use this formula is we could go through the derivation, which I'm not going to, but the way that we're going to use it is by saying the distance is equal to the square root of the difference of x sub 2 minus x sub 1, that difference squared, plus y sub 2 minus y sub 1, that distance squared also. Let's go through an example. Let's say that we want to find the distance between 2 points, minus 2, 2, and 3, minus 6. It doesn't matter which pair that we label x sub 1, y sub 1, or x sub 2, y sub 2. There are subscripts of 1 and 2, and those just identify which is pair 1 and which is pair 2. It makes absolutely no difference which one that we choose to be point 1. Our ending answer will be identical. So I get to choose, and I'm going to call minus 2, 2 point sub 1 and label the x and y values with a subscript of 1. Remember that an ordered pair has both an x and a y value. So therefore, the minus 2, 2 will be the point 1, and it will have subscripts of 1. So we've labeled it x sub 1, y sub 1, making the x sub 1 equal the negative 2 that's directly above it, and the y sub 1 equal the 2 that's directly above it. Now what I have to do is call the other point 3 minus 6, point 2, and give it the subscripts of 2. So that makes x sub 2 be equal to 3, y sub 2 be equal to negative 6. Now I know what all four of my values are, as seen here on the line right here where we have all four of them listed. So I'm going to go through and take my formula, which was listed above, it's highlighted in the yellow, and go through and use straight substitution. So therefore, x sub 2 is equal to 3. I have a minus sign in between them. I put that minus sign down, and then I go get my value of x sub 1, which was negative 2. I go get y sub 2, which is a negative 6. I put my minus sign down, which was between them, and then I get my value of y sub 1, which is 2. I've now substituted in, and it's a matter of just going through the rules for the order of operation. So minus minus 2 is a positive 2. I have 3 plus 2, which is 5. 5 squared is 5 times 5, or 25. I have minus 6 minus 2, it gets more negative, giving me a minus 8. Minus 8 squared is minus 8 times minus 8, giving me 64. 25 plus 64 is the square root of 89. I can leave it as the square root of 89, or I could get a calculator out and see that the square root of 89 is approximately 9.43. The symbol for approximation is those little squiggly kind of equal sign. Sometimes people like the visual example of graphing it better than going through the formula. I'll show you how to do that. You don't need to know how to do both of them. Pick whichever one is easier for you. So I've graphed the 2 points, minus 2, 2, and 3, negative 6. I formed a right triangle by making that point minus 2, minus 6 down there, and then connecting the dots, making a right triangle. If I go through and I count the length of that leg, I can use the lines on the chart. So I would start here at minus 2, 2. There's 1, 2, 3, 4, 5, 6, 7, 8. So the length of this vertical leg is equal to 8. The length of the horizontal leg starting at minus 2, minus 6 would be 1, 2, 3, 4, 5. So the length of the horizontal leg is 5. I get exactly the same results that I did before using that formula, or I can go through and use the Pythagorean theorem and substitute. So I know the length of one leg is 8, 8 squared is 64, the length of the other leg was 5, which was 25, and I get the distance squared is equal to 89. Taking the square root of both sides, I get the distance is the square root of 89, exactly the same answer. So use either the formula or the graphical method, whichever one is easiest for you. Try this next problem without looking at the answer. Try to calculate and find the distance between the 2 points, minus 1, 4, and 1, negative 2. Use either the formula in yellow or try the graphical method if you want. Here's how I worked this problem. I chose the point negative 1, 4 as point 1, making x sub 1, y sub 1 be minus 1, 4. Therefore, x sub 1 is negative 1, y sub 1 is 4. I chose 1, negative 2 as my second point, making x sub 2 be equal to 1 and y sub 2 be equal to negative 2. Then I went through and used substitution with those four values into the formula. Doing my substitution, I get 1 minus a minus 1, that difference squared, plus minus 2 minus 4, that difference squared. The bottom line, it gives me 4 plus 36, the square root of 40. You can leave your answer as that, or if you want to, you can go ahead and calculate the result.